start our first physics topic, rotational motion. Rotational motion is also called as rigid body dynamics. Now, consider a pulley. Here you can see a pulley. In this pulley, from this hinge point, rest of this hinge point, every part of the pulley is rotating. But in this hinge point, there is no rotation because here hinge point, at this hinge point, the acceleration is 0. That is, acceleration at the center of mass is 0. Okay, that is the reason here you have external forces to the sum is equal to 0. That is, when acceleration at the center of mass is 0, external forces or total external force is equal to 0. In this rigid body dynamics, you can see that every rigid body, particular 2 points are being rotated with same angular velocity, because in this rigid body there will be no difference in that 2 points, any 2 points. So you can see that example of door. Now in this door, from this edge, the door is flipping that side and this side. From this edge, based on this is axis of rotation, this edge is called as axis of rotation. Again, you can see this fan also. In this fan also, from the center point, everything is rotating. Angular, slowly it's gaining angular acceleration. Every point is different, having same angular velocity. Okay. Now, coming to concept, kinematics in rotational motion. Kinematics in rotational motion. S is equal to r theta. Okay. Pi S is equal to r theta. Now, see, this is a rigid body. This is axis. This is a particular point P. Now, this particular point is rotated like this, okay, by an angle theta. This is r and angular displacement is theta. So it is called as distance is angular. Distance is equal to S equal to r theta. For a particular time delta t, there will be delta theta angular displacement. We know velocity is equal to distance by time. Similarly, omega, that is angular velocity, is equal to d theta by dt. Okay. Now, kinematic equations. Rotational dynamics equations. Rotational dynamics equations. What is the analog? S equal to ut plus half at square. Then here we will be writing theta is equal to omega naught t plus half alpha t square. V is equal to u plus at. Omega final is equal to omega initial plus alpha t. V square is equal to u square plus 2as. Omega final square is equal to omega initial square plus 2 alpha theta. This is we are here, both equations are similar, but notations you are getting different. Here you are getting s theta, but the meaning also is accurately not, but somewhat similar, because it is in rotational motion, it is in linear motion. That's all. Now, you can see in ceiling fan, angle of rotation is increasing. As increasing the time, angle of rotation is also increasing, then angular acceleration also increases. That is, as the angular velocity is increasing, angular acceleration is increasing. Okay, that is angular acceleration. alpha is equal to d omega by dt. Okay, now let's see a question. Yeah, read the question. The motor of an engine is rotating about its axis with an angular velocity of 100 revolutions per minute. It comes to rest in 15 seconds after being switched off. Assuming constant angular acceleration, calculate the number of revolutions made by it before coming to rest. Just pause the video and try it. Okay, now initial angular velocity. In the question we have initial angular velocity is equal to 100 revolutions per minute. That is, we know 10 pi by 3 radians per second. Also we have final angular velocity is equal to 0 and time interval is 15 seconds. Now we want alpha. Now we have an equation about this. Omega is equal to omega final omega initial plus alpha t. Omega final is 0, omega initial is 10 pi by 3, and alpha we don't know, and we want this time we know. Then what is alpha? We'll be getting minus 10 pi by 3 by 15, right? Then this is 2, this is 3, then it is minus 2 by 9 pi radians per second square. This is first. Then what is the angle rotated by the motor, right? Then we have one more equation, theta is equal to omega initial t plus half alpha t square. And omega initial we have 10 pi by 3 radians per second. Next time is 15 plus half into seconds plus half into alpha, we have find it 2 pi by 9 radians per second square. And then again time. We can solve this, right? After solving this, you will be getting 25 pi radians. That is again 12.5 revolutions per second, revolutions per minute. Yeah, this is of minute only, right? Hence the motor rotates through 12.5 revolutions before coming rest. Till its coming rest, it rotates 12.5 revolutions. Now, one more question. Read. Starting from rest, a fan takes 5 seconds to attain the maximum speed of 400 revolutions per minute. Assuming constant acceleration, find the time taken by the fan in attaining half the maximum speed. Okay. Now, what here I got? 400 revolutions per minute. Okay. Now, second question. We have omega final is equal to omega initial plus alpha t. Then omega final we have maximum speed, that is 400. Then it's starting from rest, so omega initial will be 0 plus alpha into time is given as 5 seconds. Then we will be getting alpha is equal to 80. Okay, we'll be thinking t is a time. It will be taking till it attains 200 revolutions per minute, which is half the maximum. Okay, they have told it's maximum, so we should find the half of it. Then it's 200, right? Then 200 revolutions per minute. Then what is the time? Alpha we have found now only t. And what is the time? 2.5 seconds. Simple, right? Yeah. No. Next, coming to concept again. Coming back to concept again. Relation between the linear motion of particle of rigid body and its rotation. Right? Relation between the linear motion of a particle of rigid body and its rotation. Yeah, let's consider a point in the rigid body, point P. It's rotating about this axis, right? Rotating about this axis, then we can see, we have already known that now v into ds by dt is, a velocity that is equal to r omega. Similarly, acceleration is equal to dv by dt, that is r d omega by dt, that is r alpha. So we got v is equal to r omega and a is equal to r alpha. Remember, this is used in rest of the problem. Most of the problems you will be using this, so remember these formulas. They are very simple also. Now coming to one simple problem. A bucket is being lowered down into a well through a rope passing over a fixed pulley of radius 10 centimeters. Assume that the rope does not slip on the pulley. Find the angular velocity and angular acceleration of the pulley at instant when the bucket is going down at the speed of 20 centimeters per second and has acceleration of 4 meters per second. Just pause the video and try it once. Now, angular velocity here, angular velocity is given as omega is equal to v by r, that is we have given 20 centimeters per second by 10 centimeters, that will be equal to 2 centimeters per second. And angular acceleration is also given here. Angular acceleration, that is alpha is equal to a by r, that is 400 by 10 radians, that is 40 radians per second. Okay, now let's continue with our topic. Now again we are getting into torque of a force about the axis of rotation. Okay, about the axis of rotation I will studying now. Now let there be a rigid body and at point P there is a force, right? F is a force, point P and F is the force. Okay, let this may be one point and let us take another point here. Then both the points should be on the axis of rotation. Okay, axis of rotation, see, like this, on the axis of rotation. Okay, then now what we know, that torque is equal to r bar cross f bar. Yes, torque is a vector quantity. Okay, torque is a vector quantity. Torque is equal to r bar cross f bar. Then here on this whole point you can see at anywhere, as long as it is chosen on this line, that will be same. What will be same? Torque will be same. So how it is happening? Let's check it out. Then OP bar cross F bar, that is equal to O1 O dash bar plus OP bar into F bar, right? This is the point, right? Now O dash O cross F bar plus OP bar cross F bar. Then what is happening here? O dash O cross F bar will be perpendicular to O dash O. How it will be perpendicular? We know when a vector, two vectors are cross product, it will be perpendicular to this vector. Then this O dash O is perpendicular to F bar, this vector perpendicular to this vector. So what will happen? We know torque R bar cross F bar cos theta. Cos theta means cos 90. Cos 90 means it's 0. So at any point on this line, axis of rotation, the torque is 0. Like this, some cases are there where torque is 0. Let's check that cases also. Case 1, when F bar is parallel to A bar, then R bar cross F bar is perpendicular to F bar, right? See, let this may the axis of rotation. Then F bar is like this, parallel to F bar, this AB bar. Okay, this is distance R. Then what will be this vector R bar cross F bar? It will be perpendicular to F bar. Then again what happened? It is again perpendicular to AB also. So it again R bar cross F bar cos theta is again cos 90, that is 0. Now one more case. Case 2. F bar intersects AB. This is also in this case also that is 0, because taking a point on intersection, again this R bar is equal to OF. Here you can see O P F, like this. It's passing through O also. Then R bar is equal to OF bar. Then OF bar and F bar both are same lines. In the same lines, what will happen? Torque will be automatically 0, right? So here torque will be 0 here also, because R bar cross F bar are same lines. Then cross product is 0. A bar cross A bar is 0, right? Like that only. Same vectors, if we are taking cross product, then what will happen? It will be 0 automatically. Next, case 3. Case 3. F bar is perpendicular to A bar. But how? As Q lines. See, let's consider this is in our room. Okay, on this one wall the line is like this, parallel. Another wall, the line is like this. The two lines are perpendicular, but it is not intersecting anywhere. This is called, these are called as, we know, skew lines, right? These lines are called as skew lines. Then what to do? Here also you will be getting, and there is no point where R bar cross F bar is going to be happening. So again it's 0. And resultant force on the body is 0. Its torque decides angular acceleration, right? See, when we are studying the starting of this discussion, that external force is 0 when ACM is 0. Okay, so torque is equal to I alpha also. This is new relation we are getting. This is most important relation, one of the most important relation in whole rotational dynamics, and it will be continuing in further chapters also. Now we have studied resultant force is 0 lastly. Okay, resultant torque is not 0, right? When resultant force is 0 also, here you can see in this fan case only, here resultant force is external force is 0 because of center of acceleration of center of mass is 0, but torque is not 0. Why? Because as torque is not 0 only, it's rotating, right? So that's why we can say either when external force is 0 also, but here torque may not be 0. Okay, we know that in linear acceleration of the particle, the total force on a particle should be non-zero, but in rotation motion the torque about the axis of rotation must not be zero. See, here maybe because in linear motion, when force is zero, automatically acceleration will be zero. Here also in the same case, but here no motion is taking place, but here motion is taking place. That's the difference. Let a particle be in rotation on the circular, you see, like this. There is a circular disc, and it is rotating like this. This particle is block. Let it be a block. It's rotating like this. And what will happen when rotating like this? Here also we are getting center of mass acceleration, ACM is 0, but here we are getting this torque we are getting. So this is an important example. We can say that torque will be present. Now, what is rotational acceleration? We will study about that. Forces, tangential acceleration, tangential that thing. Now, starting with radial acceleration. Radial acceleration of a particle. Radial acceleration of a particle is v square by r. That is how we can say. Again, v square means we know v is equal to omega r, omega square r square by r, and omega square r is acceleration, radial acceleration. And again we know force is equal to ma, then force is equal to m into omega square r. This is most important relation in finding out time period in most of the cases in laws of motion also. Again we know tangential acceleration, A is equal to dv by dt. We studied it earlier also. Then tangential force, what about tangential force? F is equal to ma, then A is alpha, right? Next, we know that torque is equal to I alpha. Then I is, we know that mi r square, right? Here sum of whole, like this one body, you can take it. Let us consider this body is in equilibrium. Then forces are acting on like this: F1, F2, F3, F4, F5. Then what to do? Forces are acting like this. All these forces, combined forces, summing only, we will get torque external total. That is called sigma mi ri square alpha. That is only I alpha. I is sigma mi ri square. Okay. This force is in equilibrium, so because here we can see it is in xy plane, these forces all will be coming to, torques will be coming to 0. Why? External, but perpendicular like this, the forces which are far away, f dash, f1 dash, f2 dash, these we will be getting these torques. Because these are intersecting, so we have learned what we have learned. Intersecting means it is of same vectors. So r bar plus f bar which means same vectors, so we will be getting it as 0. Now that is only bodies in equilibrium also we have studied. Here this is only bodies in equilibrium. This body is, whole body is in equilibrium. Then let us see, let us say that one only. If say F1, F2, F3, F4, F5. The center of mass of the body remains in equilibrium if the total external force acting on the body is 0. This is the statement we are studying from first line of this chapter onwards. Similarly, the body remains in rotational equilibrium if the external torque acting on the system is 0. See, now only we have discussed, if these points are intersecting, then you will be getting the torque as 0. Why? R bar cross F bar vectors both will be of similar vectors, so it will be 0. So here we can say Fx is also 0 and Fy is also 0. Force, because forces are along axis and on the plane intersecting the plane. So here the forces are 0. Okay. Here we are ending this part 1. Tomorrow we will be learning about angular momentum, conservation of angular momentum, and rest of some may be remaining, and we will be covering some problems also. By Monday or Tuesday we will be completing this. 2-3 sessions extra. Thank you for watching. I hope you have enjoyed, and make sure you are subscribing, liking the video. If you want any other topic, clearly you make comment in the comment box. I'll be making the video for you also. Thank you.